Large language models are awesome. They have already captivated the whole world with their capabilities in variety of applications such as language generation, understanding, reasoning, and lot of other things. But still, they struggle to provide accurate answers when faced with complicated tasks. To improve the performance of LLMs, some of the recent research tools applications have focused on ensemble methods. In these methods, multiple LLM agents are used to improve the performance of LLMs. For example, LLM debate employs multiple agents in a debate form. The reasoning performance is improved by creating a framework that allows more than one agent to debate the final answer of the arithmetic task. They show performance improvements compared to using one single agent. Also, another project called as COT SC generates multiple thought chains and picks the most self-consistent one as the final answer. The reasoning performance is improved by involving more thought chains compared to chain of thought, which employs a single thought chain. Incidentally, from the data analysis of these works, we can notice the effects of putting multiple agents together to some extent, and that can lead to a performance improvement in certain problems. This project, called as More Agent is All You Need, shows that adding more agents increases LLM accuracy using a simple sampling and voting techniques, as you can see in your screen. Tests across various LLMs benchmark show that this approach improves performance significantly, especially when it comes to complicated tasks. For example, with 15 agents, Llama 2 13 billion equals Llama 2 70 billion accuracy. And with 15 to 20 agents, Llama 2 70 billion and GPT 3.5 Turbo reach the accuracy of their more powerful versions. The code of this project has also been shared, but I have no idea why they have put it on a very strange, weird site, which is called as some anonymous GitHub instead of putting it on a regular Git repository. So unfortunately, I won't be able to show you it in action. But so really, I mean, so as you can see on your screen, this is somewhere very weird anonymous dot for open dot science. They have put it in here. I mean, why they have done it, I have no idea. So it is. I have tried to download it from there, but it is not accessible. So I won't be able to show you. But as per their documentation, all you need to do is to either set OpenAI's key, or if you're using Azure, the IP and OpenAI key, and you can use it, or you can even use it with any open source LLM. I was planning to use it with Olama, but as I said, this very strange, and I have no idea why they would do this thing. Anyway, so having said that, let's go and try to learn more about this. So we already know what exactly this is doing. So if you look at this picture, what is happening here is that this is a two-phase process, which begins by feeding the task query either alone or combined with prompt engineering methods into LLM agents to generate answers. And then majority voting is applied to these answers to determine the final answer. And then an LLM agent refers to a single LLM or a multiple LLM agents collaboration framework. So there are two phases in this one: sampling and voting. So for example, if you look at sampling, and let's say that X represents the task query and M denote an LLM. And then, so in this phase of sampling, they generate N samples by solely querying the LLM Mn times, with each sample represented at S is equal to Mx. And there are a lot of maths involved, so you can read it in your paper. I will drop the link in video's description. So when it comes to voting, they employ majority voting to consolidate the response sample into the final answer, which makes it quite easy. So all in all, if I try to summarize what they have done here in this paper, they present the first systematic study on the scaling property of raw agents instantiated by LLMs, and they have found out that the performance scales with the increase of agents using the simplest way of sampling and voting. And then they have also explored the compatibility of their method with existing complicated methods, that stimulate the potential of LLMs, revealing that their method can enhance these methods to achieve further performance improvements. And then they analyzed the effectiveness of their method in tackling problems at varying difficulties and then distilled the properties behind, based upon which they propose further optimization method, which you can read in this paper. All in all, a real good research, but unfortunately won't be able to test it because of this uh, brain thing. That's it, guys. Let me know what do you think. If you know any easy way of getting the code from this link, let me know in the comment, and I will make another video and try to show you the demo. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps. Thanks for watching.